Hello and welcome to Virtual Learning Network. This e-lecture is on Computer Basics and PC Software, Block 2, Unit 2, Introduction to Operating System. The topics we are going to cover are Introduction, the concept of an operating system services, command processor and user interface, file management, input-output services, process control management, memory management, a bit of history, summary. Let's start with introduction. An operating system is software, which may be viewed as an organized collection of software consisting of procedures for operating a computer and providing an environment for execution of programs. It acts as an interface between user and the hardware of a computer system. The concept of operating system. The basic objectives of an operating system are to make the computer system convenient to use and to utilize computer hardware in an efficient manner. An operating system has a large collection of software which manages the resources of the computer system such as memory, processor, file system and input-output devices. It provides two basic types of services. It accepts requests from users and from the users' programs and execute their commands. It optimally manages the hardware resources of the computer, which may include CPU, main memory, etc. This figure shows the command interface as part of the operating system. In some system, this is viewed as a shell outside of the operating system. In a real situation, the operating system does more complex tasks. It controls not only one input-output device but many such devices. It allows many programs to share the hardware resources of system and not once. With this example, one can make out what kind of facilities operating system provides to the user and programs. The operating system provides interface for the user and allow for the user's programs. It provides file system support to manage huge volume of data into secondary storage device. It provides input-output services that can be used by every program. Operating system services, command processor and user interface, file management system, input-output control system, process management, memory management. Command processor and user interface. The most important and visible services provided by the operating system is the user interface and the capabilities that it provides to execute commands, which may not be a part of OS. Instead, these systems consider the user interface has several shells that is provided with the operating system and that interacts with the kernel to provide the necessary user command capabilities. In Unix, three different shells, the C shell, the Bourne shell and the Korn shell are in common use, and many other shells for Unix are available. Each of these shells provide different command structure and different capabilities. File management. The file management system provides and maintains the mapping between a file logical storage needs and the physical location where it is stored. User and programs simply access the files by the name and the file management system handles the details. The file management system identifies and manipulates files by the names provided by their users, determines the physical requirement of the file, allocates space for it, stores it in that space and maintain the information about the file so that it may be retrieved partially or in full later. The file management system keeps track of the available space on each device connected to the system. The user and user's program need not to be aware of the underlying physical storage issues. Input-output devices. The operating system include input-output device, driver programs for each device installed on the system. These drivers provide services to the file management system and are also available through the API to other program for their use. The input-output device drivers accept input-output requests and perform the actual data transfers between the hardware and specified area of memory. Process control management. The process concept considers the program together with the resources that are assigned to it, including memory, input-output devices, time for execution. Memory management. The purpose of the memory management system is to load programs into memory in such a way as to give each program loaded the memory that it requires for execution. In multi-programming operating system, there are many programs residing in the memory simultaneously in the memory. The memory management system has three primary tasks. It attempts to perform these tasks in a way that is fair and efficient to the programs that must be loaded and executed. First, it keeps track of which parts of the memory are currently being used and by which process into memory together with the space being used, and also keep track of available space. Second, it maintains one or more queues of programs waiting to be loaded into memory as space become available based on such program criteria as priority and memory requirements. Third, when space is available, it allocates memory to the programs that are next to be loaded. It also deallocates a program's memory space when it completes execution. The deallocated space is made available for each programs. Serial processing. The programmer interacted directly with computer hardware. There was no operating system. These machines were run by operators from a console consisting of displays, lights, toggle switches, some form of input device and a printer. Programs in machine code were loaded via a card reader. This mode of operation could be termed serial processing, reflecting the fact that users have access to the computer in series. Gradually, various system software tools were developed which included libraries of common functions, linkers, loaders, debuggers, and input-output driver software to attempt to make serial programming. Gradually, various system software tools were developed which include libraries of common functions, linkers, loaders, debugger, and input-output driver software to attempt to make serial processing more efficient. Simple batch system. A batch system is when a computer is programmed to batch together a number of transactions for processing at a specific time. It introduced a simple form of multi-programming or multitasking feature that facilitated loading several jobs into main memory, so that other jobs programs could use the CPU when one job was busy with input-output. By this time, disks were also becoming available. To take its advantage, the operating system introduced features to card onto disk while the CPU execute its jobs. Thus, when a job completed, the operating system could load another job from disk into memory, ready to run. This improved the operating system scheduling capabilities. Multi-programming or multitasking is the central theme of modern operating system. Time sharing system. Time sharing is a technique which enables many people's located at various terminals to use a particular computer system at the same time. Time sharing or multitasking is a logical extension of multiprogramming. Processors time, which is shared among multiple users, simultaneously is termed as time sharing. In time sharing system, multiple users simultaneously access the system through terminals, with the operating system interleaving the execution of each user program in a short burst or quantum of computation. Both batch processing and time sharing use multiprogramming. Now it's summary time. In this unit, we learn the operating system concepts which will be discussed in advanced operating system. Operating system accepts requests from users and from users programs and executions. Repeat. Summary. In this unit, we learn the operating system concepts which will be discussed in advanced operating system. Operating system accepts requests from user and from users programs and executes their cards in optional manner. To understand an operating system are needed to understand the services provided by the operating system. Thank you for this session.